Hi everyone. So we have discussed data link layer and few responsibility of data link layer, which are error control, flow control, and framing. So these are the important responsibility of data link layer that we have seen. Now in this video, I will be moving to network layer. Now in the network layer, we have different protocols, and IP protocol is one of the protocols that we will be studying. And there are different protocol that we use as a if there is any error or something, then to report those error we use these ICMP protocols that we will study also. And before we study IP protocol or ICMP protocol, I will talk about routing protocols. So what does these protocols do? These are basically algorithms which help us or help router to design routing table. So this is routing table, and these routing tables are generated or are formed with the help of routing protocols. So in particular, we will be studying two protocols. One is distance vector routing, which is DVR, and another is link state routing, which is LS or LSR, link state routing. So we will be studying these two protocols or these two algorithms to design routing table. Now, what do I mean by routing? Suppose that there is some router which is U, and there is some another destination or another router which is V. And now you have to forward some packet to V. So now you have to decide that to which router it should forward the packet first, right? What should be the next hop? I mean, there could be multiple paths using which you can send the data either through X1 or maybe through X4 or maybe through X3 also. But suppose that X1 through X1 we are taking the least cost, or this is the shortest path. So routing algorithms decide that which path is shortest path or which path is optimal path. And for that we have two routing algorithms. One is distance vector routing and another is link state routing. So in this video we will be talking about distance vector routing. Now in distance vector routing, what we do, suppose like this is the configuration that we have and these are the routers that we have, and this C and B, like as shown in this diagram, are connected with one link that is having a cost of 1, which could be anything. Like we can determine the cost based on many parameters, maybe delay, maybe number of hops between them, or there could be any other parameter also. So I'm just calling them cost. So they are connected with the cost of 1. Similarly, A and B are connected with the cost of 7. And I'm assuming that links are symmetric, which means either you go from A to B or B to A, both links are having cost of 7. Now in distance vector routing, what we do, we take a vector for every router. So we form a vector for every router, and then we forward these vectors to the neighbors, which means like D will say that see, I'm connected to, like D will say to E that I'm connected to C and I am just 2 distance away from C. So it will say that I'm 2 from C and 0 from D obviously and 2 from E. So D will say to E that I'm 2 from C, 0 from D and 2 from U itself, which is E, right? So this is what D will, no, like D will propagate this information to every neighbors, which means to E also, to C also. So D will also propagate this information to C. And similarly, these information will get propagated by every router to every other router. So let's see with the example. Suppose this is the configuration in which the routers are connected. Now D will make a vector which is called distance vector, and it will say that see, there are 1 2 3 4 5 routers are there. So it will say that it will be having 5 entries A B C D E, like that. Now it will say that I initially D will say that I do not know the distance to A, so it will say that it is infinity. I do not know the distance to B, it is infinity. And D will say that I know the distance to C, which is 2. I know the distance to D, which is itself 0. And now I know the distance to E, which is 2, right? So this is a distance vector at D we have initially. This is the initial configuration that we have initially. D has this information only. And what about C? C will say that see, I have information about B. About A, I will say it is infinity, B, C, D, E, let me just write first. Then it will say that about B, I have the information and I'm connected to B with the cost of 1, to C with the cost of 0, to D with the cost of 2, to E with the cost of infinity. So this is the distance vector initially distance vector for C. This is a distance vector for D, right? Initially this is the configuration. Similarly, I will be having distance vector for every router. Now for E, I will say that A, B, C, D, E. E is connected to A via 1, via B, B via 8 cost, and to C via infinity, to D via 2, to E via 0. So this is a distance vector of E. Distance vector of E, right? Similarly, I will be having distance vectors for A and B also. Now, once you have these distance vectors, now this algorithm says that you just pass this information to the neighbors, which means I will pass this vector to the neighbors. So D will pass this information to C and to E. Similarly, E will pass this information to A and to D. Now, if I talk about D, then D will be getting the information from neighbors, which means C and E. So from D perspective only, let's suppose I am at D. So I am at D, I will be getting information from what are the nodes? From C. So I will be getting one vector from C. Let's suppose this is the vector I am getting from C, and this is a vector that I am getting from, let's suppose, E. From E. So what is the vector that I will be getting from C? This is the vector, which means infinity, 1, 0, 2, infinity. And then from E, I will be getting 1, 8, infinity, 2, 0. 1, 8, infinity, 2, and 0. So this is A, B, C, D, E. It means what? That at D, I will be having two vectors, and it means that at D, I will say that from C, if I want to go to A, then I have to incur the cost of infinity. And from E, if I want to go to C, to A, then I will incur the cost of 1. So these vectors are telling that if you want to go from E, then what are the costs? If you want to go from C, then what are the costs? Now based on that, D will compute its new vector, right? How? It will say that if I want to go to A, then I have two options, either via C or via E. There are only two options. And if I go via A, then it will take infinity time or infinity cost. If I go via E, then it will take 1 cost. So obviously via E is better, right? So it will write it, let me just write it. So it will write 1, but to E itself it will take the cost of 2, right? So let me write these costs here. So to E it will take 2 costs, and to C also it will take 2 costs. So instead of directly comparing this infinity and 1, it will compare infinity plus 2. Basically it will add this 2, because to go to C only it will take cost of 2. So basically infinity plus 2 is just infinity, 3, 2, 4, and infinity. So it will compare this with what? It will add 2 here, 3 and 10, infinity, 5 and 2. So it will compare these two. Now, and as we know that this is A, B, C, D, E. As we know that from D to D itself is 0. So anyway it will write 0 first, and then it will be comparing these two. Now you just compare infinity and 3, then obviously 3 is minimum. Compare 3 and 10, obviously 3 is minimum. Compare 2 and infinity, 2 is minimum. And you do not need to compare, because from D to D it is already 0. Then compare this infinity and 2, then 2 is minimum. That's how D is updating its own vector, right? I hope you got it. How D is updating? It is just checking if I have two options, either via C or via E, then which one is better. And first it is adding the cost to go to C or E itself, right? The cost to go to C and E is 2 and 2. So I'm first adding that, and then it is comparing between that. I hope you got it. So this is just like one round of updation, like that will happen till it converges. So I will show you the complete example, but I hope you got the one round that how it is happening. So what's going to happen? Every node is going to transmit its distance vector to the neighbors, and at the neighbor I will be having multiple distance vectors. Then I just need to compare those, and I just need to update the values, right? So this is what is happening. This is the example I have taken from 10 and 1. So let's suppose that this J, at J I'm checking what are the vectors I will be getting. So I will be getting from I, because I is a neighbor, from A, and A is a neighbor. from K, and from H. So I will be getting A, I, H, and K. From these four nodes, I will be getting vectors from J, vectors at J. So at J, I will be getting four vectors. Suppose like these are the cost in the vectors I have. Okay, so I am not showing the cost here. Like I have written in the vector itself. So suppose these are the cost. So what it will do, and suppose that from J to A it is taking 8. So 8 is written here. Earlier it was taking 2 and 2 in both the cases, but here it is taking 8. And from J to I it is taking suppose 10. From J to H it is taking 12. From J to H it is taking 12, and from J to K it is taking 6. Suppose this is the case, which means like now it will compare these four values, but not directly. It will first add 8 in this vector, 10 in this vector, 12 in this vector, and 6 in this vector, and then it will compare all these four values and it will write it here. So if you add this 8 in this vector, so it will be 8, it will be 34, it will be like more than 30, it will also be more than 20 something. So 8 is minimum, right? Similarly you can find it out for every for every other vector. And here from J to J, obviously I will be writing just 0, right? Here you do not need to compare. Here always write 0, because from J to J I will be taking 0. And this is the next hop. Like I mean, if you are taking like this line is just telling me that if you are taking the minimum from A vector, so I'm just writing A. Okay. So why that is necessary? Why I'm writing that I will tell you a little later. But here in this diagram, here A means that the minimum is from A, and this A means the minimum of this row is from A again. This I means the minimum from this row is from I. So this 28 is minimum, because 18 plus 10, 28 is minimum compared to every other value, right? So this is what I'm writing here, that the cost is 28, but the next hop, like using which I should go, is basically I, which also makes sense, right? I mean, J should not only know that what is the minimum cost, right? It should also know that what should be the next hop. So suppose that from J you want to go to C, right? You want to go to C. It is not enough to just tell that it will take 28 cost. It is from J, if you want to go to C, it is not just enough to like it will take 28 cost. It is also necessary to know at from J's point of view that what should be the next hop. So the next hop is I in this case. So the packet from J will get forwarded to I, and then from I, like based on the distance vector and routing table, I must have calculated the whole routing table, and then from I will forward accordingly. So in this case I only have one option. So from I it will go to E, and then I will like this is how routing is working, and then from E, based on the next hop, I will forward that packet, right? So I hope you got the idea that what we were doing. So what we are doing, we are just taking all the vectors from the neighbors. So in this case neighbors are 4, so from all 4 neighbors I am taking the vectors, and then I'm writing those costs below, so that I can easily compute the minimum by just adding this 8 in the whole vector, 10 in this vector, 12 in this vector, and 6 in this vector, and take the minimum, and then finally calculate the distance vector for J. Now this is not the whole procedure, which means this is just one round of optation. It will keep on happening till it converges. Okay, so let me take one example and let me show you the complete algorithm, that how it is working. Yeah, before example, this is just a pseudocode of the algorithm. So it says that wait until I see a link cost change to some neighbor, which means suppose that this is the graph, and then suppose that this is the initially 5 and 6, something like that, these are the costs, and suppose that this cost drop down to 2 immediately, like something happens and then this cost drop down to 2. Then what will happen to distance vector of this router? It will immediately update that, let's suppose this is A, this is B, this is C, then B, like B will immediately update that if you want to go to A, then the distance was earlier 5, now the distance is 2. It will immediately update it. Okay, so it will wait, either some link is changed. If link is not changed, then it will wait till it gets some information from the neighbor. So once one of these two events happen, then it will quickly update its distance vector like this, and then it will propagate its distance vector to every other neighbor. So if the distance vector is changed, then it will propagate this distance vector to every other neighbor, right, to all the neighbors. Anyway, this is just a pseudocode that what we have just seen. So the idea is same, that we will be getting the distance vector from every node, and then we will be basically computing the new distance vector, right? So this pseudocode is just telling us that when to propagate or when to forward the distance vectors. So it is just saying that if there is some link change, then you will be changing the distance vector immediately. Or if you get some information, right? If you get some information from some other node, then just update this distance vector. And if it got really updated, then propagate this distance vector to every other neighbor. This is the same thing, like this is the pseudocode, like flowchart of the pseudocode. This is the same thing which says that wait and then recompute. If there is a change, then notify every other neighbor and just keep on doing it, right?